Hi, thank you very much for having me here. The title of my talk is Finding the Best Configuration in Distributed Architectures Through Generic Algorithms. So nice to meet you. I am Yury Niño. I am Cloud Infrastructure Engineer at Google. Also, I am Site Reliability Engineer, Advocate, and passionate by Chaos Engineering. That they are our websites if you like to visit us. So this is the agenda for the next 15 minutes. I am going to start with a short description of distributed architectures, and I am going to detail one recurrent problem when we have to design and implement this type of solutions. After, I will explain how can we use patterns and specifically the circuit breaker pattern to solve these problems. However, as you know, as a solution always comes with more challenge, as the circuit breaker pattern is not the exception. So at the end, I am going to present a proposal to solve the configuration problems to the circuit breakers using generic algorithms. So let me start with a short context regarding to distributed architectures. So probably this picture is familiar for you. For me, it is a funny way to explain how our architectures evolve from the classical monolithic structures to distributed architectures based on microservices. Basically, they distribute the business logics in small components known as microservices, which abstract and implement specific functions. So, in spite of these architectures provides several benefits such as flexibility, modularity, resilience, scalability, independency, and easy of deployment. Reach these benefits impose several challenges. The most common include balancing speed and safety, data synchronization, versioning, discovering, debugging, logging, monitoring. There are a lot of things that we must think with. We are designing this type of solutions. So as you can see here, Netflix and Twitter have grown in crazy ways. So it is a visualization of their architectures. So the experience has taught the infrastructure required by a software system can be as complex as the architecture itself. The challenge here is that every production failure is unique. So there are no two incidents that share the precise change of failure. So each architecture is unique and they are as complex as the organizations or the users are using them. So those problems has been grouped in anti-patterns that, for our fortune, are documented in the literature. I am talking about the butterfly pattern, Spider-Man pattern, and slow responses pattern, cascading failures pattern. So I have a few times, so I won't explain them, but here a picture of them. So the important here is that for each anti-pattern, we have a pattern solutions. For example, if you are facing slow responses, you can use patterns such as fail fast or timeouts. But if you are in the middle of a cascading failure or a blocked thread, the best way to solve it is using a circuit breaker pattern. So let me focus in the circuit breaker challenge. So for explaining this pattern, I like to use an analogy with the energy industry, in which the circuit breakers are used to protect our houses from burning. The basic idea behind the circuit breaker is very simple. You wrap a protected function called in a circuit breaker object, which monitor for failures. Once the failures reach a certain threshold, the circuit is open and all further calls to the circuit breaker return with an error. When the failing component is recovered, the circuit breaker is closed and the system returns to an operating state. That is the idea. And as mentioned, the idea behind the pattern is simple. However, its configuration, no. Calibrate the values to determine the threshold, for example, is difficult. In this table, we can see of several variables, four of several variables that we must calibrate when we are using resilience for J. For example, it is common that in all implementation, we have to define a failure rate threshold, a slow call rate threshold, a slow call duration threshold, permitted number of calls in half open state. In general, it is common to define several variables in order to configure the circuit breaker. So that is the difficult part of this challenge. So the question is, what is the proper configuration for the circuit breaker, considering that each system and organization is different? Well, I think that is a perfect use case for an optimization problem in generic algorithms, as I will explain in the next minutes. So generic algorithms are part of a family of search algorithms inspired by the principles of evolutionist nature. Basically, by imitating the process of natural selection and reproduction, generic algorithms can produce high quality solutions for various problems involving search, optimization, and learning. So generic algorithms seek to find the optimal solution for a given problem. What is the objective? Basically, the objective in generic algorithms is, or the main idea of generic algorithms is maintaining a population of candidate solutions called individuals for a given problem. These candidate solutions are iteratively evaluated and used to create a new generation of solutions. Those who are better at solving these problems have a greater chance of being selected and passing their qualities to the next generation of candidate solutions. This way, as generations go by, candidate solutions get better at solving the problem at hand. Probably it is difficult to understand in a first preview, but I have a picture that explains better. So this picture probably explains better the algorithm to find a proper solution for a problem. So let me talk about this. So in the first step, we evaluate this configuration using a proper strategy. My apologies. So in the first step, we choose an initial population for the configuration. For example, in this case, I am using random numbers to configure the failure rate threshold, slow call rate threshold, and another variables required to configure the circuit breaker, as can you see. So in a second step, we evaluate this configuration using a proper strategy. In my case, I am using the failure request obtained in a load test with Gatling, a framework to run this type of tests. As you can see, while the circuit breaker is open, as you can see here, we have a lot of rejected requests. While the system is stable, we have 0 rejected requests, as you can see here. So my metric in this case to evaluate the proper function or the proper configuration for the circuit breaker is using the failure request rejected request. So if the results are not satisfactory, we choose another random configuration. I cross over this configuration with the first one and evaluate again and iterate in this way. So eventually we can configure the algorithm for mutating the results. That is another proper way to test another random configuration. So finally, when the termination criterion, in my case, the rejected request or an acceptable rejected request, we will be reached, we can finish the process. So that is the solution. So finally, I would like to close this talk with a phrase by Charles Darwin. It is not the strongest of the species that survive, nor the most intelligent, but the one who is most adaptable to change. So I had a few times. So that is the slides. In the slides, you can find more information about these algorithms and about this configuration. But basically, the idea is to use generic algorithms in order to test the universe of solutions, combining solutions in a crossover way. So that is all. And thank you very much. My name is Yury Niño Roa. So that is my webpage, and that is my username in Twitter, LinkedIn, and Instagram. If you can get more information about this technique in order to solve problems with configurations for patterns in order to solve distributed architectures problems. And thank you very much. That is all.